So given that this is basically the final talk for the week, I've tried my best to keep this more lightweight, so it's not, a deep technical talk. It's more just random thoughts that I've had around the on-chain and off-chain ecosystem for a while, and based on what we're building as well. So that's basically what the topic's going to be. So if you want to interrupt me at any stage and just ask a question, you can unmute yourself and just make a comment. I'll probably seek some comments anyway. So what I want to start off with is the on-chain part. And this is more for historical context. So I got into Bitcoin back in 2013, and I got really excited for, eCash and being able to send money over the internet and pay for stuff. This is a screenshot I had from Bitcoin Core back in 2013. It was the payment protocol. It said you're paying the bitpay.com and you're going to send it to this address. Unfortunately, they've removed all of this now. I think that's a bit of a shame. So this is more like historical context. But back then, people thought Bitcoin would be really useful for merchant payments. I could go on an online shop and I could buy, I think I bought some stuff. I bought like t-shirts. They were really silly purchases because I wanted to try it. Andrew bought a bunch of weird stuff as well back in 2011. I'm trying to remember what it was now. It was some Bitcoin. What did you buy in 2011, Andrew? You bought like some Bitcoin thing.
A small bear trap.
A bear trap?
Some socks, peanut butter.
Okay, socks and peanut butter. Okay,
put the YouTube link somewhere.
Yeah, I think that's where I've seen it. So obviously back then, everyone thought Bitcoin would be really useful for e-cash and e-payments. And since 2020, this is an article from CoinDesk, there's roughly been around $4 billion worth of volume in payments for Bitcoin. And that sounds like a big deal for, 1 year's worth of volume. But then when you look at, what people actually transfer in Bitcoin, this is I think this is actually a Bitfinex transaction, but in a single transaction, they transferred $1 billion from one cold storage to another. So these would be 4 of those, and they've overtaken all of the volume of Bitcoin merchant payments. So $4 billion isn't really that impressive. When was the last time someone here bought something using Bitcoin? Did anyone buy anything recently using Bitcoin for any merchant payment? You're on mute. And did you buy anything? No one's bought anything recently.
No.
Exactly. Oh, who was speaking? Okay, that's fine. I thought I heard someone speaking. Maybe it was just me. And that's a pretty big deal. Oh crap! I don't want to open the link. So what has this got to do with on-chain? Why are people not buying stuff with Bitcoin? I mean, one is the user experience. No one wants to wait around for an hour to buy something. Although if it's online and you're buying from a website online, then actually it's not that inconvenient to wait an hour for a payment to confirm. I don't know why my slides are going like this for. But the real reason why a lot of people don't want to pay for this is simply the transaction fee. And why does the fee go up? As everyone here is probably aware, blockchains are the knapsack problem, or bin packing problem. You have a block that's 1 megabyte, 2 megabyte, and Ethereum it's 10, 12 million gas, and you have a list of pending transactions. If there's not many pending transactions and they can all fit in the block, then there's no fee pressure whatsoever. If there's lots of transactions in the memory pool, and the memory pool is like 2 or 3 or 4 or 5 or 10 times bigger than the bag, now there's a fee market. People have to compete to get inside that bag, and becomes a first price auction in terms of trying to get inside that bag and outcompete each other. And we've sort of seen this already with the ICO boom. This is a chart I just took from blockchain.com. Apparently in 2018, there was $20 million worth of fees around some period of time. That means it'd be about $58 per transaction. I remember at one point it was $20 per transaction. And you don't really ever want to pay $20 per transaction if you're buying socks or peanut butter. So it doesn't do that use case anymore. And this week I looked at the little bottom chart here to see what the price was. It's about $5 per transaction, give or take. So that's not really reasonable for merchant payments. So one of the reasons I got into Bitcoin was because I thought it was cool eCash. And actually it turns out not to be useful for that at all. So what is it useful for? Why would someone pay $5 or $20 for a transaction? And there's really a couple of reasons why you would do that. For Bitcoin, as everyone's aware, Tether took up most of the block space for about a couple of years. And what people are really doing there is just transferring coins from one exchange to another, and they want to get some arbitrage moment for that. So they're willing to pay a $20 fee because if they get on Bitstamp fast enough, they can make over $20 worth of profit. As well, Bitcoin is more useful for high net worth individuals. If you're transferring millions of dollars, like someone transferred $1 billion, you're more than happy to pay a $5 fee to transfer a high amount of money. Or cross-border transactions. So one example is China. They have capital controls. You can only transfer $50,000 out of the country at any one time. You get your hands on Bitcoin, you can bypass that capital control completely, and you're more than willing to pay $20 for that. But the thing about Bitcoin is that, the value for sending this transaction is implicit. It's really difficult to measure, the amount of money or value you get out of sending a transaction for $5. Where the Ethereum world, it's very explicit. If I'm going to do let's just say I'm going to go on Aviv, I'm going to get a flash loan, I'll do a couple of trades in Uniswap, and within that single transaction, I can make Y profit, I can make $100 worth of profit. Then actually, you can quite easily measure this, say I may be willing to pay $90 because I'm going to make $100, so I'll make $10 profit by doing that transaction. Other use cases is managing your crop. That's more of a joke because people are yield farming at the moment and it's full of crops. But this is actually one subtle difference I've noticed between Bitcoin and Ethereum. Bitcoin, the value of a transaction is implicit. Ethereum seems to be more explicit or easy to measure using the blockchain. If you have any comments on that, just unmute yourself and comment away. I'm more than happy to have people comment on this. But this actually also gets reflected in the transaction fees. So this is actually from our pitch deck for Anydot that I stole a while ago. And you can see here in the start of 2020, Ethereum fees were 1/4 of Bitcoin. One of the Bitcoin maxis were also basically highlighting that, during an ETH bear market, the fees are way higher compared to Bitcoin. Even they're acknowledging the fees in Ethereum. And then by another date in January, 5 days later, the fees were half of Bitcoin. And recently in July, the fees in Ethereum recently overtook Bitcoin as well. One day, and I think this was yesterday was paid, 21st of July, $1.2 million in fees. Bitcoin's just under $1 million in fees. And I think that really highlights, because in Ethereum, you do have this explicit reason to send a transaction at a high fee, because you're going to make profit within that single transaction. And that obviously has implications for the network. One thing I do want to highlight before that is, now as we know there's a bin packing problem, there's all of these, a huge list of transactions that are all competing to get in the blockchain. And in Ethereum, you're willing to pay whatever it takes to get in because you're going to make X amount of profit doing that. So how do people today compete in that fee market? I took this thread from Twitter. It's from like a few days ago, early July. Basically what they're saying is, the UX is a nightmare. What you should do is go into the advanced menu in MetaMask, set your gas fee. You should always look at ETH gas station in advance. And then, you send a transaction, the fee isn't good enough. You go into MetaMask, settings, advanced, customize transaction amounts. And then you have to set your fee and, trying to make the transaction feel. And this is a terrible user experience for everyone interacting with Ethereum. You literally have to go down 4 menu options to cancel a transaction because the fee wasn't good enough and now the transaction isn't worth doing anything. So how are people going to compete in this fee market going forward for the next few years, assuming that, the base chain doesn't scale that well and there's always going to be some market, less than pending transactions that are seeking to get accepted into the main chain. And I guess what's going to happen is that most people are going to have specialized relayers. That's one of the reasons we built a relayer called Anydot Sender. That have all these companies in the background, they're going to outsource this to someone who specializes in basically front-running others on the network. Because actually what you need to do is look at the mempool, look at the top 10 million gas, and then outcompete everyone there. And we're starting to see that a lot of services now have their own specialized relayers. A lot of them sort of break down after a while, but this is sort of starting to emerge, that people want to have a service for this. But what about the miners? I haven't really spoke about the miners. They're the ones collecting all the fees for these, these auctions on Ethereum. Phil gave a talk earlier this week about miner extractable value, so I don't really want to repeat his talk. But what is interesting is that obviously miners control the order of transactions in a block. They take the transactions out of the pending pool, they create the block, and they broadcast this to the network. So what people are doing today, they incentivize getting their transaction in the block first, getting their trade executed, and making their $100. they're actually doing these gas auctions on Ethereum. So within a 14-second window, between block 1 and block 2, there's an arbitrage moment, and they'll make $100. So one bot will send it in at a low gas fee. Another bot will find that, they'll copy and paste it, they'll send the transaction in with a slightly higher fee. Now you have all these bots, quickly bumping up the fee within the 14-second window until their transaction gets into Ethereum. And whoever pays the most will hopefully be the first in the block and then collect that fee. And is this a good thing that people are, doing these gas auctions to compete for these blocks? The bad, the good outcome is that there's actually a way to measure how much value can be extracted from the blockchain. People are willing to pay X, then they're probably making they're making Y, and Y and X are probably really close. So you can actually extract now you can actually measure all this extractable value. Yeah, so that's the good thing about it. But the question is there a better way to do that? Because if you spam the network with all these transactions, now what you get is a block with one trade and a list of failed transactions. They still take up space in the blockchain. Miners are stoked when you include them because they have really high fees, but they don't do anything. And then this impacts everyone else who wants to use the blockchain because it basically becomes a network for gas auctions. That doesn't seem like a very efficient way to do arbitrage. So what the Optimism team sort of propose, and actually one thing I should highlight is what miners could do instead of these gas auctions, what miners could do is, miners get to pick the transactions. So miners could just copy and paste the trade, stick it in their block, and outcompete everyone else. So if you try to do a gas auction, it's not going to make a difference because the miner will just front run everyone. And that's typically seen as a bad thing. If miners can front run everyone, they sort of undermine these gas auctions and they extract all the value for themselves. But the Optimism team have this quirky idea of a MEV auction. So if I want, to do arbitrage on all these DeFi applications, instead of participating in these real-time gas auctions, I could bid for the right to create a block. And if I can bid for the right to create a block, what I could do with my block is then extract all of the value out of everyone's trades. And then I use that for my profit. So I'm no longer doing any real-time gas auctions. I'm actually doing something that's the same machine learning to do the best bin packing algorithm to maximize my value. And then I give that to the miner. The question is that a good thing or a bad thing for people to do? I mean, the good thing is that it's more efficient for the network because now you're not going to have all these failed transactions. The other side of it is that it's a bit like going on the Phoenix exchange back in 2017. The exchange is actively trying to front run against you and steal all the value from your trades. Does anyone want to use an exchange that's going to front run you every single time? Probably not. So I just thought I'd bring this up because it's quite an interesting dynamic for these the on-chain fee market that no one really talks about. And there's not that too much research into this so far. So that's the on-chain part. And if you have any questions about the on-chain part, I'm more than happy to chat about it now. You can just unmute yourself. Okay, I don't think anyone has many comments. So now what I want to talk about is the off-chain part. So obviously, if the main chain is limited and can't process every transaction, and in fact, it's going to get expensive because of all these gas auctions, there's value in sending a transaction with a high fee. That means I'm no longer going to be able to do merchant payments. I'm not going to buy socks or peanut butter using this chain. So people looked at off-chain protocols to do this. So I remember back in 2015, or I guess 2016, actually it was more 2015 this was released. I think maybe they've updated the date there when they refiled LITAC. But, Lightning was really exciting at the time because people thought, well, instead of sending all the transactions to the blockchain, why don't we take the transactions off-chain and run it locally between the parties? If we can build this really cool payment network, then we don't have to worry about the bin packing problem anymore because everything's off-chain. And ideally, if everything's off-chain and local, there's no throughput limitation there. And I'm sure maybe some people remember this slide from the original Joseph Poon presentation when he was trying to explain the Lightning Network, because the paper itself was a bit terrible. You get halfway through a paragraph as it drops off and doesn't complete the sentences. And the slides were probably more useful for learning it. And the community went for it, given a lot of the limitations in Bitcoin, they've all rallied around the Lightning Network and they've built out the stack what you need to start setting up payment channels and sending transactions. And this is I took the screenshot today. There's 30,000 channels, and actually this time last year there were also 30,000 channels. So it looks like the channels have, kept constant. There's this ecosystem evolving. You have all these different companies doing gaming, payments, wallets, hardware development, laps. But in reality, there was a lot of hype, let's say January 2019, but it appears the Lightning Network is just like stalled. It's frozen. It's not really progressed much in the past year. I just want to ask anyone here, has anyone done a Lightning payment in the past few months? Just unmute yourself and say, yeah, you've done a Lightning payment in the past few months.
I've done one.
Okay, you've done one. Awesome. So we got one person who's done a Lightning payment then. Awesome. But that's important. Lightning is not getting that much traction. Is it because, the ecosystem is still early? They haven't got maybe, merchants aren't really accepting it yet. The infrastructure isn't there. Or maybe, I've deleted the slide. Or maybe it's just not very good for payments, just like Bitcoin. So I want to explore sort of what would be the problems of why this would not be good for payments. So if you're a payment channel hub, I want to route payments on the network, what I need is a large pot of money to allocate to all of the channels. Alice comes along, I put 2 coins in the channel for Alice, and Alice can now Alice can receive 2 coins on the network, but she can't send any coins. Bob comes along, Bob puts in 2 coins, I put in 2 coins, Bob can send 2 coins, and he can receive 2 coins at any one time at this present. Caroline comes along, Caroline can take, send a coin, but she can't receive any coins. And then we have Dave. I really like Dave. I give Dave 4 coins, and he can receive up to 4 coins right now. When we take a deeper look at this scenario, as I mentioned, Caroline can only send 1 coin, she can't receive anything. That's annoying if you want to receive payments on the network. You need incoming capacity. Alice can hold up to 2 coins at any time. If she's running an event and she needs to sell 1,000 event tickets, she needs to have incoming capacity up to that amount. That may not be realistic because then you have to buy the right to do that. And this is like an example. If I go to Bitrefill at the time, I'd have to pay 0.0048 Bitcoin in order to receive 16 million Satoshi. And that doesn't really make a lot of sense if I'm a merchant and I want to receive payments. It restricts the amount of flow that I can have at any one time. And you need 1 on-chain transaction to join the network. So I can't just send you a Lightning payment at any time. You must have a channel up front and you must have an on-chain transaction to do that. So the onboard, 4 billion people, you're going to need 4 billion transactions to hit Bitcoin if you want to remain non-custodial. And that's, again, Bitcoin doesn't scale to do that. So maybe the Lightning Network isn't very good for payments. So what is it useful for if it's not good for payments? And I'm going to get to that very soon. Because it is useful, but I don't think it's useful for payments. And hopefully I get to that point, but I only have 10 minutes left. So then Plasma came around in 2017. Everyone got really excited for Plasma. Again, it was going to save the day and scale Ethereum. And the idea in Plasma is really simple. I'm a block producer. I have millions of customers. They all have coins locked into my service. They send transactions to me. I create a block. I then get a little checkpoint, I hash it, and I send a little checkpoint to Ethereum. And I just do that periodically. Alice sends a coin to Bob. I take that transaction, I post a little checkpoint, and it gets confirmed. So the data is off-chain, the computation is off-chain, and there's no real collateral lockup for the operator. As you can see here, Alice puts in coins, Bob's going to receive a coin, but the operator doesn't need any coins up front. They can just run this service immediately. And you're literally moving the coin from Alice to Bob when you do the transfer, and you send that checkpoint to Ethereum. So that's really cool as an idea. And that looks really great and an awesome way to scale the network, but there's some fundamental problems with it. As I mentioned, you post a checkpoint for every new block, and that's basically just a hash of the state in the transaction list to keep it very simple. So what might happen, and this is really the big problem for Plasma, is the data availability problem. What if the operator posts a checkpoint, but they don't post the witness or the data? The only way to force the operator to reveal the data is in the issue on-chain challenges on Ethereum. You say, well, given this checkpoint, can you reveal my balance on Ethereum? So now you have all these user challenges against the hub. That's sort of the no-cost model. And checkpoint integrity. What if I just post the hash if Paddy is cool? You need to then have challenges on Ethereum in order to prove the integrity of the checkpoint and then make sure all the transactions are valid. So the operator could withhold data. You need on-chain challenges. The checkpoint could be invalid. And, there's different ways you can guarantee that integrity for that. Why do these problems even exist? At a very high level, you have the operator, you have the blockchain protocol, and you have this consensus protocol. Typically on Ethereum, you post all the transactions. You assume that they can store all the transactions, they can verify all the transactions in real time. But for Plasma, the operators creating these blocks off-chain and posting checkpoints, and you assume the smart contract, which is on Ethereum, it lacks computational resources and it lacks storage. It can't store every rollup block. It can't verify every transaction in rollup. And you assume there's third-party observers that can validate this in real time and then post challenges when it's necessary. And when you dive into the problem, a reason why Plasma is no longer very popular is because in order for Plasma to be secure, in terms of data availability, mostly data availability, you have to assume a reliable layer 1 system that could issue all the data availability challenges within that epoch. And so far, layer 1 doesn't really scale well for that. So that's why a lot of people have sort of not been very eager to pursue Plasma. So then everyone thought, well, if data availability is the big problem, why don't we just post all the data to Ethereum per block? You get, instead of posting hashes and checkpoints, just post the entire rollup block. And that's rollup. That's basically the difference between rollup and Plasma. Plasma, the data is off-chain. Rollup, you just say, well, let's compress the data. When I say compress, the transaction's like, I think it's like, I'm trying to think what the gas is now. It's not very much gas anyway. Let's say it's 100 gas. You just basically post the call data, the data off the transaction. And that's basically what most people are building right now. And when you really think about the rollup situation, you got the entire block, you're posting that to Ethereum, and you're keeping the computation off-chain. So maybe you post a rollup block in a snark, and you prove that given this block, it has integrity because there's a snark that proves that everything's well-formed. Or you post a rollup block, you have an epoch for the challenges to be posted, and anyone could prove that a part of that, a small part of that rollup block is invalid. It could be this non-interactive, challenge where you say, look at this part of the rollup block is definitely invalid. And that's basically what people are doing now. Fraud proofs or zero knowledge proofs. That was sort of the topic for the panel yesterday. And what may actually end up happening is now, instead of these specialized relayers competing on behalf of other people, these rollup providers, they sequence all of the transactions and they post their rollup blocks to Ethereum. But you still have to post all the data, so it kicks the can, you're kicking the can down the road for scalability. Data is now your bottleneck on Ethereum. It's no longer computation. And obviously there's still going to be a scaling limit. But I'm just going to finish up now. I've actually got just in time, so I'm quite happy with this. So what about, I can't even pronounce the word, interoperability. Apologies, my English is terrible. I'm Irish, speak broken English. But the question is there, you have two rollup blocks. One's maybe MetaMask where you have your balance, then you have Uniswap and you want to perform a trade. It's exactly the same as the sharding problem. How do I get my coins from the MetaMask rollup and I go to the or how do I get my coins from the MetaMask rollup and I can then do a trade in Uniswap and then go back to the rollup with my funds? Just like in sharding, maybe one way to do it is to withdraw your coins from the rollup on Ethereum, deposit them on Uniswap, do your trade, withdraw from Uniswap, and then go back to MetaMask. And that's obviously very slow and expensive. It's sort of like asynchronous. It's you have to do a lot of transactions to get there. Could even be worse. Maybe you want to get a flash loan from Aviv and then do your trade in Uniswap. So you have a transaction in, out, in, out, in, out, and no one really wants to do that. So actually, this is sort of where payment channels might be very useful, and I don't think many people have explored this idea. Well, maybe they're not really good for payments, but they're good for synchrony. You have these intermediary nodes. I have a Lightning channel on the MetaMask rollup. I have a Lightning channel on the Aviv rollup. And what and then maybe Andrew wants to send coins from the MetaMask up to Aviv, then the Uniswap, and that could be a his TLC transfer where you just say in the Uniswap chain, execute this trade if a pre-image is revealed before time t, and then it could flow right across the rollups and come back again. And that would be really cool because payment channels work best when there's bi-directional traffic going rapidly back and forth. They don't work very well when traffic's going one direction. So maybe they're synchrony channels, and maybe that's actually where they'll finally get use and people will actually want to have a payment channel. And then all these crazy channel operators with thousands of channels, they're specialized as just guaranteeing synchrony between these rollups or these shards. I just wanted to throw that out there. It's been a thought I've had for a while, and I've not really seen many people talk about it. So that's basically the end of my talk. Thank you very much for listening. As I mentioned, it's a very high-level talk. Cool.
Thanks a lot, Patty. We have time for, I think, one quick question, if anybody has one.
I'd love to hear even more on, I think it's exciting that you've identified a potential new use for payment channels on the synchrony topic. I know we had been talking for, I think, many years now on like what else you can use state channels, off-chain channels for. That's kind of compelling. It seems like you're, floating a potential new idea. Could you say even more about it? Like, what would we expect to see happen first? How could we investigate this and make it happen?
So I think the issue is that we sort of got the synchrony for channels before the rule. I mean, we had this payment channel thing, and we thought we knew it was useful for rapid off-chain transactions, but we sort of got the routing network. Oh yeah, we sort of got the routing network before we got the central operators that were non-custodial. I think these will just naturally evolve as people start transferring their funds to rollups, and then they think about it, doing these crazy rapid things. I think in terms of how they move it forward, it'd be really good to test, how well that synchrony could actually work. I mean, because the problem with TLCs is the free American call option problem, where you could set up the trade and then you lock that trade in for an hour or two, and you lock up all the collateral, and then actually can't do it because there's not enough collateral to facilitate that. So maybe one interesting thing would be, are you better doing a TLC versus rapid micro payments like Interledger approach, where they're not trust-free? You could lose a penny in the trade, but maybe it offers better synchrony for doing this.
Do you know these projects like Bolt Labs and like Arwin? Those seem to be instances of what you're describing, right? They're like HTLC-based off-chain exchanges, basically. But you were talking about these kind of like multiple layers. So does that mean that it would be like an off-chain HTLC-based stable coin or something like that?
Yeah, you could have stable coins there. I mean, it could be any value that you're transferring. So, I mean, actually, another interesting thing would be to look at is the exchange rate. I mean, we always talk about Lightning working across, payment channel networks working across multiple blockchains, where actually this is still the multiple blockchain case. So if I'm on MetaMask, I have ETH. When I get the Uniswap, I'm trading my ETH for socks. And on the way back, I need my socks back. So I need one path there, one path back. And the exchange rate, someone's taking on the exchange rate risk for that. So that's also another problem that would have to be looked at. Is that viable if the exchange rate could be locked up for 2 hours?
Interesting.
Yeah, I mean, that's cool. Anyway, I can stop now because I don't want to hold up the panel. But thank you guys for listening.